All right, are we ready? So this is problem 29, and we're going to go through A through C. For this problem, we need to find the probability of each event. So the first probability in part A says we need to find the probability drawing a diamond from a standard deck of cards. Now I know that diamond is one of the 4 suits in a deck of cards. I know that there are 52 cards all together, so that is my whole. And now I need to figure out what my part is. So if I had a diamond, I know I have a diamond as an ace, as a 2, a 3, a 4, a 5. I'm going to keep counting all the way up to a king, and I know that in a deck of cards, each suit has 13. So the probability of pulling a diamond out of a full deck of cards would be 13 out of 52, which is also equal to 25%. All right, for part B, we need to find the probability of rolling a number less than 5 on a number cube. So we know that there's 6 sides to a number cube. So my whole is 6. And I want to find the probability of finding a number less than 5. So that means that's 4, 3, 2, and 1. So I have 4 out of 6 chances of rolling a number less than 5. And that equals 66 point, I think, 6% or 7%. All right, last one. We're going to find the probability of drawing a blue marble from a bag of 18 marbles, and we know that 3 of them are blue. So if we have a total, our whole is 18 marbles, and we know 3 of them are blue, our probability is going to be 3/18, or 16 67 hundredths of a percent. I hope that helped. I'll see you soon. Hey class. So right now what we're going to do is problem 32, and we're going to do A and B. And with these problems you had to find the area of a parallelogram. And for problem B you had to find the area of a triangle. So I'm going to walk you through both of those problems. So in the first problem you have a parallelogram where your sides are equal, kind of like a square but a little slanted. And in this problem we want to look at our little table right here and the dotted line. Whenever you see a dotted line like here, and if you have your measurement, that's going to be really important. That is telling us right there the height of our parallelogram. And I should tell you this, when we're finding area, we need to find 2 things. The area of a parallelogram is base times height. So right here, this dotted line tells us our height, but even also more important is this little table. So that table tells us that that is worth 90 degrees. And always from the base of the table, the dotted line tells us the height. And the line that the table rests on, this solid line down here that is 27 inches, that will always tell us that that is our base. So where the table is sitting, it's like the base, it's like the floor. That's our base right there. So we're going to plug in some values. We have area equals our base, which is 27, and our height, which is 17. And we're going to multiply that, and our area equals, I think it's 459. And since we're talking about area, it's going to be in square, and we're talking about inches, so it's going to be in square inches. So that's your area for problem A. All right, moving on to problem B, what I see here is we have a triangle. And again, we need to find the area. One thing I know that is a triangle is half of a parallelogram. You can think about a parallelogram as a square. Cut the square in half, you'll have a triangle. So what we're going to do is we're going to treat this triangle as a parallelogram, and I'm going to find area equals base times height. But then what I'm going to do is I'm going to cut that in half. So I either can say divide by 2, or I can say area equals base times height, and I can multiply it by 1/2. It's going to give me the same answer. So what we're going to do here is we have, here is my dotted line, and here is my table that I was telling you about. I can see that it's resting on this line that is 20 and 75 hundredths of a meter. So I'm going to measure A equals my base, which is 20.75, times my height, which is 9 meters. Okay, I'm going to cheat and use my calculator. So 20 0.75 times 9 is 186 and 75 hundredths. But I'm not done yet. What I need to do is now take my 186 and 75 hundredths, and I'm going to multiply it by 1/2 or divide it by 2, whatever you prefer. And that is going to give me area equals 93.375. I'm going to round up to area equals 93 and 38 square meters. And that's my answer for problem 32. Hi class, this is kind of new, me in front of the camera, but I'm trying out a new system, so see how this works. I'm going to be reviewing a few problems today. We have quite a few. They're from chapter 5, and so you can look and you can follow along in the book. I'll also kind of be summarizing the problem, but I probably won't be reading it. I'll just be doing the work on the board. For our first problem, we're going to do problem 38 in chapter 5. And with this problem, what you had to do is you had to find the chances of winning in game 1, and you had to find the chances of winning in game 2, and you had to see which one was a better chance of winning. So I'm going to do parts A and B for you, and then I hope by that time you can go on to part C. So for part A, you had to find the prime number, any number between 1 and 20. And a prime number, just to remind you, is a number that can only be divisible by 1 and itself. So, and it had to be above 1. So our first prime number is 2. The only numbers that can be divided by 2 evenly are 1 and 2. Our next one is 3, 5, 7. 8 wouldn't work because we can also divide 8 by 2 and 4, so that's not going to work, sorry. So we have 7, we have 9's not going to work either. We have 10, no, but we have 11, 13, no 15 because it can be divided by 3 and 5. We have 17 and 19. So out of the numbers between 1 and 20, 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 20 numbers are prime numbers. So that is our chances of winning for game 1. Let's see about game 2. Game 2, we're going to count them up. So 21 is not prime, 22 is not prime, 23 is prime. And we're going to keep counting up. 24 is not prime, 25 is not prime, 26 is not prime, 27 is not prime, 28 is not prime, and 29 is prime. 30 no, but 31 is. 32 is not prime, 33 is not prime, and the next prime number actually we have is 37. All the other numbers between 21 and 40 are actually, they can be divided by different numbers. So in this case, our chances of winning for game 2 are 4 out of 20. So out of 8 out of 20 versus 4 out of 20, your chances of winning game 1 are going to be better. All right. The next thing we're going to do is part B. So for part B, similar, you have to find a multiple of 5 in 1 through 20. So that's going to be 5, 10, 15, and 20. That is 4 out of 20. Or if I simplify that, that's 1/5. Okay? For game 2, it's part B is picking a multiple of 5 and 1 and 40. So that's going to be 5, 10, 15, 20, 25, 30, 35, and 40. I want to make sure I wrote that down correctly. Yep. So obviously there you have a lot more chances. You have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 chances out of 20. Even if we simplify that, that would be 4, let's see, 4/10. Even if we simplify that a little bit more, that would be 2/5. 2/5 is greater than 1/5, so we're going to go like that. All right, so hopefully from there you can figure out problem C.